Hello, students, and welcome to our lesson today. We will do an interesting do now today. We're going to talk a little bit about not so good listening skills or poor listening skills. Sometimes when we look at what we shouldn't do, it helps remind us what we should do. Our objective today will be to learn to evaluate functions, and we will also use something called function notation, the way we write functions. Our essential question, we have several, we have two. What notation distinguishes a function, and what important steps should I take when evaluating functions? Our assignment today will be to watch the video, and we have 2 pages assigned. For our exit ticket, I want you to complete this sentence. Function notation is especially useful for finding a value in the range that corresponds to a certain what value. For homework tonight, we'll do homework number 4. We're evaluating functions and function notation. It's 1 page. And I just want to remind you that if you have been sent a spreadsheet, I want you to catch up on whatever assignments that you need to finish up. Let's get this quarter 2 off to a good start. We're breezing right through our unit on functions. Before you know it, we'll be on direct and inverse variation and then on to slope. So your homework, I know I don't collect it all right away, but you should do it when it's assigned because that's what keeps you sharp. And that's what makes each subsequent lesson easier. So my little gift for you today is this beautiful drawing. I love this colorful paisley turkey, and it says a grateful heart is a magnet for miracles. And I know that in my life, when I've been more grateful and thankful for things, it did attract more good things to happen to me. So that's my little gift to you for today. I think it's very pretty. Excuse me. So we're asking an odd question today. What does bad listening look like and feel like? And when I was thinking about this, I thought, well, we've talked a lot about EARS as an acronym for good listening and to really, acknowledge the other person, ask questions, repeat what they say back to them, confirm what they're saying. But if somebody isn't focused on you, what might that look like? And one thing that kind of I find that I don't feel good when I am talking to someone, I don't feel good when the camera is off when I teach because I don't know if you're listening. And also, if someone's on their phone, if you were talking to somebody, they were just kind of clicking through their phone and looking at things, that really would be a sign that they're not paying attention to you. So I want you to go ahead and write your own sentence or two about bad listening. And then I want you to not do those things and remind me not to do them. We all shouldn't do them. So we'll come back to our exit ticket. So our topic today is evaluating functions and function notation. I already spelled it wrong. Let's get that right. Evaluating functions and this function notation. Okay, so equations that represent functions are written in a slightly different form called function notation. So you might be used to an equation that's y equals. That's a function, but we write it like this: f of x equals the 4x minus 1. And that means the function of x equals 4x minus 1, or we say f of x equals, and then whatever the function is. So f of x is the output, where x is the input. So where f of x, let's say if in this case, if x equaled 1, then f of 1 would equal 4 times 1 minus 1, which would equal 4 times 1 is 4 minus 1, which would equal 3. So f of 1 would equal 3. So we're going to do some evaluating, very simple to what I've just done. And we'll start with this same function, f of x equals 4x minus 1. And this is very important. So why do we like this function notation? Well, function notation is especially useful for finding a value in the range, those are the y values, that corresponds to a certain domain value, the x values. So in our first example, we say if f of x equals 4x minus 1, find f of negative 7. So we would write f of negative 7 equals 4. Now, I can't say this enough. Use parentheses when you make your substitutions. And we're only substituting for x. So where you had x, put parentheses, insert what you're trying to find. 4 times negative 7 minus 1. 4 times negative 7 is negative 28. Minus 1 equals negative 29, and that's the final answer. So we're going to evaluate some functions. So we're going to evaluate f of x equals x plus 7 for f of 5. So we just rewrite the function. F of 5 equals 5 plus 7, which equals 12. So f of 5 equals 12. Here we have number 2, g of x equals 3x minus 8. Be careful, here's the semicolon, okay? So here's the function, the part I underlined in blue. And this is what we want to substitute. We want to find g of negative 3. So g of negative 3 equals 3 times negative 3 minus 8. So that equals negative 9 minus 8, which equals negative 17. Just substituting, but be very careful when you do that. So h of x equals 2/3 x minus 1. We want to find h of 9. H of 9 equals 2/3 times 9, using parentheses, minus 1. And 2/3 of 9 is 6, minus 1, and that equals 5. Let's change our color a little bit. Here we want to find, our function is f of x equals x squared minus 2. Students, we are substituting for x, not x squared. Whatever we make for our substitution will eventually be squared. But let's write it like this so I can show you. F of negative 4 equals, okay, something squared minus something. And then in there, we will put our negative 4 squared minus negative 4. Now be careful, we've got a negative times a negative there, and we're going to square a negative. So negative 4 times negative 4 is 16. Minus negative 4 is plus 4. So the final answer is 20. So try 5, 6, 7, and 8, and then come back and let's see how you did. So I hope you tried them on your own. Here we have for number 5, f of x equals x squared plus 6x minus 4, and we need to find f of 5. So f of 5 equals negative, now parentheses, okay, squared plus 6 times 5, we're only substituting for x, minus 4. So negative 5 squared is negative. Remember, the 5 was not negative in there. The negative is outside. So we have negative 25 plus 30 minus 4, working from left to right. Negative 25 plus 30 is 5, minus 4 is 1. So let's just do this much. That's 5 minus 4, which equals 1. And that's our final answer. Okay, now we have g of x equals negative 1/2 x plus 9, and we want to find g of negative 8. So g of negative 8 equals negative 1/2, use parentheses, plus 9. So negative, negative 1/2 times negative 8 is 4, positive 4 plus 9, and 4 plus 9 equals 13. Remember, we had a negative times a negative here. Okay, moving on. F of x equals 2x squared plus 4x minus 9, and we're asked to find f of negative 5. So very carefully, f of negative 5 equals 2, and then we have in parentheses negative 5, that will be squared, plus 4 times negative 5 minus 9. So negative 5 times negative 5 is 25, positive 25. 2 times 25 is 50, plus, or I should say, let's see, we've got plus negative 4, I think I forgot to put my 4. Let me redo that. I forgot to write the 4 up here. So let's just, sorry about that. Okay, forgot my 4 times negative 5 minus 9. Okay, let's be careful with the order of operations. So it will end up being 2 times 25, because negative 5 times negative 5 is 25, plus 4 times negative 5 is negative 20, minus 9. So 2 times 25 is 50. Oops. Minus 20 minus 9, and all of that equals 21. It's 50 minus 29, it's 21. So now going on, now we have an absolute value example, a little more work. So we have g of x equals the absolute value of x minus x squared, and we want to find g of negative 7. So g of negative 7 equals the absolute value of negative 7 minus negative 7 squared, absolute value of all of that. Let's start with the exponent. So we've got the absolute value of negative 7 minus negative 7 times negative 7 is a positive 49, still absolute value. Negative 7 minus 49 is the absolute value of negative 56, and the absolute value of negative 56 is 56. And that's our final answer. So go ahead and try 9 and 10, and then we'll come back for these more difficult combination ones. Okay, so f of x equals 4x plus 11. Find f of c plus 7. So careful, just follow carefully. F of c plus 7 equals 4. We substitute c plus 7 plus 11. And when we evaluate it, we distribute 4c plus 28 plus 11. We can combine the 28 and the 11 to get 4c plus 39, and that's the final answer. Can't do any more. Now on number 10, h of x equals negative 9 minus x, and they want us to find h of 2k minus 5. So we want to find h of 2k minus 5, which will equal negative 9 minus, I'm going to put this in parentheses, the substitution 2k minus 5. Remember, a negative sign outside of a quantity in parentheses changes the sign of everything in parentheses. So first we distribute that negative sign, which gives us negative 2k plus 5. And we can combine the negative 9 and the positive 5 to give us negative 2k minus 4, and that is a final answer. So now the next 4 are a little bit tricky, the next 6, but especially the next 4. We're adding a little bit on to these functions. So we're working with f of x equals 8 minus 3x. We're working with g of x equals 8 squared plus 2x, and h of x equals negative 5 halves x minus 1. So I actually started to write these out. So here's our 3 functions, 1, 2, 3. And in number 11, we're asked to find f of 4. Then we're also asked to add 9 to the end. Well, f of x, this first function, is 8 minus 3x. So I've got 8 minus 3, and instead of x, I'm going to put this 4. But then I'm also asked to add 9. So this is what I'm going to evaluate. So that would be 8 minus 3 times 4 is 12 plus 9. And 8 minus 12 is negative 4 plus 9. And together that equals 5. Do you see how we did that? So let's try another one. We're asked to find, let's go back to the paper. We need to put that answer too. That was an answer of 5. But we do want to show your work. I showed it on the other paper. Always show your work. Okay, so now we want negative 2 times g of negative 5. So here's g, which is x squared plus 2x. We want to multiply all of that by negative 2, and the function, we want to find negative 5 in the function. So here I've already put my negative 2. My function will be, I put it in brackets because I'm already using parentheses. Where I have g, I will substitute for negative 5. Okay, so I've just basically, where I have x, I put negative 5. Where I have 2x, I put 2 times negative 5. So now I evaluate from the inside out. So I'm going to have negative 2, and negative 5 times negative 5 is 25, plus negative 10. And we could write this negative 2 times the quantity of 25 minus 10. And that would be negative 2 times 15, which equals negative 30. And that's a final answer. So let's go and add that to our paper. Okay, so number 13. We're getting a little more complicated. For number 13, we're asked to find g of 4. So we're working with this g of x equals x squared plus 2x. And then we're adding g of negative 1. So let's go to where I put number 13. We need g of 4 plus g of negative 1. Remember, g is x squared plus 2x. So let's make our substitutions. So this first section here is going to be our g of 4. So we put 4 here and 4 here. Plus, and then this will be our g of -1. So -1 here and here. So let's evaluate that. So 4 squared plus 2 times 4 plus -1 squared plus 2 times -1 is 16 plus 8 plus -1 times -1 is 1, and 2 times -1 is -2. And 16 plus 8 plus 1 minus 2 equals 23. Do you want to try the next one on your own? It's a little bit tricky, but you can kind of model it after what I've done here. We're being asked to find 3 times h of 2, and then from that, subtract f of -9. So try that on your own and then come back. Okay, let's see how you did. Let's get a new color ready. So we have 3 times, now here is h of 2, this part. So we need to put a 2 right there. Minus, okay, this is our minus right here, f of -9. So here's our f of -9. So let's start evaluating that. So we're going to have 3 times the quantity of -5/2 times 2 is -5. So let's keep that in brackets. -1. So that's the first one. Then we have minus 8. And -3 times -9 is positive 27. So let's continue to evaluate. -5 minus 1 is -6. I could have switched to parentheses there, it doesn't matter. 8 plus 27 is is 35, so minus 35. I can remove the parentheses there. 3 times -6 is -18 minus 35, and our final answer is -53. How did you do? So let's go back and write that down, -53. So this is -53, and we forgot to put our other answer. Remember, you're showing your work. We showed our work on the other paper today. These last two, 15 and 16, those are, I think, a little easier than the ones we just did. They're saying if f of x equals -13, find x. All we need to do is set f of x equal to -13. So f of x is 8 minus 3x, and we set it equal to -13. So let's subtract 8 from both sides. -3x equals -21. Divide both sides by -3, and x equals 7. And then number 16, if h of x equals 39, what is x? So h of x is this third one, -5/2 x minus 1. So we just have to set that equal to 39. So -5/2 x minus 1 equals 39. First thing I want to do is I would add 1 to both sides. -5/2 x equals 40, and multiply both sides by the reciprocal. and that cancels that, and x will equal negative 16. Okay, we've got a nice word problem here. And it says anthropologists use the length of certain bones of the human skeleton to estimate the height of the living person. And one of these bones is the femur that's in your leg. To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61.41 plus 2.32x can be used. Find, this is what we're looking for, h of 46 and explain its meaning. So what we're doing here, and this is sort of the meaning, we are relating the length of the femur, which is the leg bone, to the height of, in this case, this is for, let's say, a female. So this is the height of a woman. They probably have a different function for men, I would imagine. Okay, so I did actually start working on this on our other paper here. So this is the function. H of x equals 61.41 plus 2.32 times x. They want us to find h of 46. It's just a substitution. So we have our 61.41 plus 2.32 times 46, and we just simply evaluate. So 61.41, remember addition and subtraction come after multiplication and division, plus 232 times 46. You can use a calculator for this. It's 106.72. And now when we add 61.41 to 106.72, we get 168.13. And remember, we're working in centimeters. So let's go back to our paper. 168.13. And it says find h of 46, and that's 168.13 centimeters. But it also says, 168.13 centimeters. There we go. And it said explain its meaning. So a female with a femur of 46 centimeters is 168.13 centimeters tall. And that's what that means. Okay, so let's look at a few graphs, and then we're just about done for today. So we are given some graphs, and we're asked to find each function value. So we're looking for what is the function when we have these certain x values. So what is a? What is f of negative 3? So I'm going to go over, I'm going to find negative 3, negative 1, negative 2, negative 3. And what is the y value? What is the function value? And the function value is 2. So what is the function value where and remember, the graph, I don't think I say this enough. The function is this line, which I will try to make it easier for you to see. Okay, that's the function. So let's find f of 1. So here's 1, and here's our x value of 1. When we come up to the function, we find we have a y value of 1. Now, when we have an f value of 0, we have a y value of 5. 1, 2, 3, 4, 5. And when the function is at 2, so 1, 2, where is it? There it is. When the function is at positive 2, the function value is negative 3. So that's how you read the graph of a function. So let's do this last one. You should try it yourself first. Always try it yourself first. Let's see. So the function is at negative 4. 1, 2, 3, negative 4. And the y value is 2. When the function is at 0, the y value is also 0. When the function is at 2, 1, 2, the y value is negative 2. And when the function is at 5, 1, 2, 3, 4, 5, the value of the function is negative 1. So you've worked hard today. Let's go back to our exit ticket. So function notation is especially useful for finding a value in the range, that's always our y values, that corresponds to a certain domain value, which is our x value. So we're given an x value and then we find the range. So the function notation is useful for finding a value in the range when we are given the domain value. So good job today. I'm proud of how hard you're working. Go ahead and try the homework on your own, and I know that with practice, as always, you'll be great.